The story of Irish ancestry is often painted with broad strokes, a narrative of ancient Celtic origins and a lineage deeply rooted in the Emerald Isle. Yet, recent scientific discoveries, particularly in the field of genetics, have begun to paint a far more nuanced and complex picture of Irish heritage. This tapestry of ancestry, woven over millennia, stretches far beyond the shores of Ireland, reaching back to the very cradle of civilization and encompassing waves of migration that have left their indelible mark on the island's genetic makeup. For centuries, our understanding of the past relied on archaeology, linguistics, and historical records. These disciplines offered valuable insights, but the advent of genetic analysis has revolutionized our ability to trace ancestral journeys and unravel the complexities of human migration. By examining the DNA of modern populations and comparing it with ancient DNA extracted from archaeological remains, we can now peer into the past with unprecedented clarity. This journey into the genetic history of Ireland takes us back thousands of years through waves of migration, cultural exchange, and ultimately the intermingling of lineages that have created the genetic diversity we see in Ireland today. It is a story of ancient connections, surprising origins, and the enduring legacy of human migration. In a momentous discovery that sent ripples through the world of archaeology and genetics, the skeletal remains of individuals dating back to the Bronze Age were unearthed in Ballycastle, County Antrim, Northern Ireland. These ancient bones, carefully excavated and meticulously analyzed, held within them a treasure trove of information, whispering secrets of a distant past and offering remarkable insights into the genetic origins of the Irish people. The Ballycastle skeletons, dated to around 2000 BC, provided the first ancient DNA samples from Ireland, marking a pivotal moment in our understanding of Irish ancestry. Prior to this groundbreaking discovery, our knowledge of prehistoric Ireland relied heavily on archaeological artifacts and inferences drawn from later historical records. The DNA extracted from the Ballycastle remains opened up a new avenue of exploration, allowing us to directly trace the genetic lineages of these ancient inhabitants and connect them to populations both within and beyond the British Isles. Analysis of the Ballycastle DNA revealed a fascinating connection to mainland Europe, particularly to regions now within modern-day France and Spain. This discovery suggested that the early inhabitants of Ireland were not isolated but were part of a wider network of migration and cultural exchange that spanned continental Europe. Perhaps the most extraordinary revelation to emerge from the study of ancient Irish DNA was the discovery of genetic links to a region far beyond the British Isles, Anatolia. Located in present-day Turkey, Anatolia was a cradle of early agriculture and a major crossroads of human migration. The genetic connection between the ancient inhabitants of Ireland and Anatolian populations speaks volumes about the interconnectedness of human history and the vast distances our ancestors traversed. This genetic link suggests that the ancestors of the Ballycastle individuals, and by extension, a significant portion of the Irish population, were descended from early farmers who migrated out of Anatolia thousands of years ago, spreading agriculture and their genes across Europe. This wave of migration, known as the Neolithic Revolution, transformed the European landscape both culturally and genetically, and left an enduring legacy on the genetic makeup of many modern populations, including the Irish. The Anatolian connection adds a fascinating layer to the story of Irish ancestry, demonstrating that the roots of the Irish people extend far beyond the Emerald Isle, reaching back to the very heart of early civilization.